When you pour milk and sugar into a hot cup of tea and give it a stir, you're witnessing the basic laws of chemistry in action. Look around you. Every single thing you touch, drink, or breathe is built from a very small set of basic chemical ingredients. Chemists organize all this physical matter into 3 specific groups: elements, compounds, and mixtures. By learning how to identify these 3 categories, we can figure out exactly how the materials in our world are put together and how we can take them apart. We start with the elements. These are the simplest raw ingredients in the universe. You cannot break them down into anything smaller. If you dig up pure gold in Karamoja or smelt a piece of pure iron, you are holding a raw element. Looking at this diagram, you can see why. An element is made of exactly one type of atom, shown here as identical blue spheres packed closely together. Think of an atom in an element like a single person walking alone through a busy Kampala market. They are completely independent. Because they are completely uniform, elements provide the reliable, unchanging foundation that we use to build everything else. But what happens when you force 2 completely different elements to permanently lock together? You get a compound. You probably ate one today: regular table salt. It is a stable material you can safely sprinkle on food, yet the raw ingredients of salt are dangerous on their own. It is made from sodium, a metal that explodes when it touches water, and chlorine, a poisonous green gas. When these 2 elements react, their atoms permanently join. This chemical bond creates a brand new substance with unique, safe properties. Like 2 people gripping hands tightly in a crowd, those different atoms form a single, inseparable unit. Nature uses compounds to create stable materials that act differently from the ingredients that originally formed them. Then we have mixtures. This is what happens when you physically stir things together, but the atoms never actually lock hands or form a bond. Think back to our tea. The sugar is the ingredient getting dissolved, and the water is the liquid doing the work. When you're finished, you have a clear solution where the sugar is still there, just broken into pieces too small to see. Because the parts of a mixture are just floating next to each other, you can usually pull them apart again using simple physical tricks, like heating or filtering. Miners at Lake Kotwe use this principle. They take a muddy mixture from the pans and evaporate the water to leave the pure salt behind. Mechanics rely on mixtures, too. To run a 2-stroke boda engine, they blend oil and petrol until they become one smooth, uniform liquid. Whether it is a cup of sweet tea or a tank of engine fuel, a mixture is just a temporary crowd of substances that keep their original identities. But sometimes 2 liquids completely refuse to join the crowd. If you try to mix thick, raw palm oil with ordinary tap water, you'll see a different behavior. These are liquids that simply refuse to blend together. Instead of mixing, the stubborn oil will immediately push away from the water and float right to the surface. These separate, stacked layers are physical proof that the 2 substances are actively rejecting each other. So if you are holding a glass of clear liquid, how do you prove if it's pure water or a mixture of water and hidden salt? On this boiling point graph, pure substances follow strict rules. Pure water boils at an unchanging temperature, flatlining perfectly at 100 degrees Celsius. But look at this second, wavering line. Mixtures bend the rules, boiling over an unpredictable, shifting temperature range. This table summarizes the rules of manner. Elements are your raw ingredients, compounds are chemically baked together, and mixtures are just casually stirred. Every time you cook a meal or fuel an engine, you are interacting with the same fundamental chemistry that builds the entire universe.